everybody, it's Bruce and the dog on the floor, and today we are going to integrate our boundary layer into our LiveView. Okay, so let's open things up and take a look at the code that we've already built. Okay, this is game, and you can see that we have most of the moves that we want to be able to do. We have a down, a left, a right, and a rotate. And these things are basically reducers, but they're reducers over game. So that means they have all of these individual pieces, right? There's points. We're not storing anything in those yet. And then there's the score and there's the junkyard. Okay, so we only have this tiny constructor that allows us to get a new tetromino and do a show there. And then we have all of these reducers that will allow us to move. Now we're reducing over game instead of the tetromino. That means that we'll basically move the tetromino, track any points if they're ready to show, change the score if it needs to be stored. We'll actually manipulate our junkyard that has all the tetrominos that were left behind that we essentially clean up row by row in the game, manipulating the score. So let's try to add the chunks little by little. Okay, so we're going to start this with our game live. And for now, we're going to disconnect our timer. So actually, let's comment this completely out. Let's click there, there, and there. Comment that out. So now we don't have to worry about things moving down. We can just kind of reason through this one little chunk at a time. So hopefully we don't need to show anymore because the points will be tracked from the game instead. And actually, instead of a new tetromino, let's get a new game and have the game be responsible for getting a new tetromino, right? Okay, so let's say, let's find where we get a new game. So there's the reducer for a new tetromino. Let's basically grab that pattern, new game, and that's going to take a socket. Remember, the socket is the state for a LiveView, and we need to add something to the socket. We need to add a game. And we're going to say we need a new game. That's game.new. So that has our constructor, and let's see if that constructor, yes, it in fact does assign a new tetromino and does assign points. So we don't need to do any of that anymore. I'm actually going to break this out of full screen mode. I think I have enough room to work with this. Okay, so I actually believe that we don't need the show anymore. I think that we're going to manage the points inside the game instead. So let's see where we see show. So these can all go away. That one, that one, that one. Yeah, these can all go away. Okay, so the new flow is I take a socket and a new game. So now we can collapse this a little bit. I think it'll look better. So we're going to say new game, and that's a reducer over socket. Right, and we can close this up. Now we don't need those lines. That's nice and tidy. Right, so that new game actually goes and gets a new game, but that means that we need to change the way that we render. So we're actually going to grab the location from the game.tetro. Inspect tetro, and let's actually inspect game.tetro. Okay, so all of these, the new tetromino isn't going to do this anymore. So I'm actually going to say the new tetromino is going to put in the game. And I'm going to pass the game.new tetromino. That looks good to me. Okay, so now the only last point that we need to consider is what about when we start to render? So we're rendering the points, and I'm going to say for X, Y, and shape comes from points, but that doesn't come from points anymore. That comes from game.points. Okay, and that looks like it should work just fine. So now let's try to compile this. Okay, so I have a couple of unused variables. It looks like line 18 looks like X and Y. That's probably some renegade debugging information. So that's line 18. Yeah, look at that. So we don't even use those anymore. I bet that bug has been there a while. And we see that game new is undefined because we haven't imported it. And game.new tetromino is not defined because we haven't imported those. So we have that constructor and the reducer that we pull out of there. So do we still need tetromino? New tetromino. Yeah, so we're going to still need that for a little while and temporarily. So we'll keep that one in place until we actually remove the last vestiges of that API. Okay, so now this thing should compile or get closer to it anyway. Oh, it does take a game, right? Socket. Okay, so now basically the difference is that we were putting a tetromino directly into the socket, and now we're putting a more complex element into the socket, the game, which has the tetromino, the points, and the score, and all the other things that we need. Okay, and now it also has this thing that we're calling the junkyard. So we're going to compile it and mix phoenix.server. Let's see if this looks a little better. Okay. Yeah, so now we are actually getting this shape, but we're not able to move it or do anything like that. And in fact, if I try to move left, I'm going to click the left key. That's going to break because tetromino is no longer in the socket, right? So what do we need to do to fix that? Well, our reducer now lives in a different place. So if there's a left, so the nice thing is that if you can see the keystroke that is arrow left, all we're doing is reducing over the socket with a left, with a move left. And so this move left, rather than picking this up, picking up the tetro, I want to pick up the game, don't I? Right? So that is the game. Now I'm going to move left with the game, and I'm going to reduce over game instead. And so let's see if that much has worked. So I can take that, and I can reload it. Let's try to move left. That's not giving me any juice. So I'm going to go ahead. I'm going to try to move this left. Let's see what's happening here. Okay, so it looks like there's some debugging information in place, probably from an earlier run. We can use that though. So in point, yeah, I have this thing called inbounds, and I'm not checking whether it's valid here. So it would have to be in, I'd have to be checking, yes. So you can see that I'm piping this points.valid to IO inspect. So it looks like things are valid. So it looks like the moved tetromino is the maybe move, right? So what I'd like to do is inspect the old and the new, and see if those are in fact what we expect them to be. So I'm going to reload this, and I'm going to click left, and now I ought to see, okay, so it does look like this wants to be moving, but it doesn't look like we're actually putting the extra pieces into our, so we're not getting the show, we're not populating the points in this Tetris in our overall game. So I bet one of the things that could help us is actually to see if we're doing the show. So the move function, yeah, so it looks like this is doing a move. And we do a maybe move, and then we do a show. So it's doing a show right here, which should put the new points into the tetromino. It's probably that we're updating our socket poorly. Yeah, and sure enough, look at this. You could see that there's the down. I wonder if we made the same problem with left. Yeah, look at that. We're updating the tetro instead of the game. Okay, so now if we move left, yeah, we're moving to the left just fine. Okay, so we ought to be able to take this success and extract that same pattern here to the right and the down, well, at least to the right. So let's grab this much. Right, so that is the same. And this is a game, and this is a game. Okay, so this ought to move us left and right, left, up, and then off the screen. So I can move left. If I try to move right, I break. And let's just take a look at our code real quick and see what we missed. So this is right. Game, right. Okay. So there we go. Left, right, left. Okay, so that's hitting the wall. And look at that. It's valid false, and it's staying in the same place, which is exactly what we want it to do. Left and right, and I come right off the wall. And right, and I hit the wall, and I stick right on the wall. So this is nice. This is working as we expect it to. So now we can play the same game with down. So here's a problem. We're actually trying to grab the location from the tetro, but that's not at the top level of assigns anymore. We need to pick up the game, and then from there, get the rest of it. So let's see. This is a little bit too deep, probably deeper than I want it to be. We'll leave with it. We'll live with it for a little bit more. Okay, so now I'm going to recompile. And it looks like I am, okay, so I'm not getting any downs. And the reason that I'm not getting downs now is that I haven't enabled my tick again. But let's go ahead and pick up the game here. This is also going to be a game, and this is going to be a game. So we're picking up the game from the socket. We're rewriting the game to the socket by calling game.down on the socket, our reducer. Okay, so now, I'm presuming that we compile, and it looks like we do, we can re-enable the tick down, and things ought to start moving down again. Or actually, before we do that, maybe we ought to do the rotate, right? So game, 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 game. And this is a game. And so now this thing ought to rotate for me well, right? So let's see how what this is looking like. So this is rotating, rotating. Beautiful. Okay. Okay, so I think that I'm actually going to allow arrow up and space to rotate, because I think I want to save the down. I want the down button actually to move me down also. And so we can also re-enable gravity, right? That's that counter that click down. So this is going down, it's going over, I'm pinned against the wall, perfect. And as it goes down too far, then I create a new one that I can move. Okay, so now what you're seeing is that our boundary layer is doing exactly what it's supposed to. It's handling the complexity and the uncertainty, and that's And you can see that the code is a little bit trickier to compile and a little bit trickier to integrate. But you can see that we've also preserved the beauty of our individual points. So moving left, it doesn't have a whole lot of checks in it, right? All it does is subtract 1 from x. And when I look at my more complex patterns, these still get to remain the same. I don't have to worry about anything rotating to an out of bounds position. And then I layer on a little bit more complexity with the points. And then when I want to worry about the complexity of the user input, then I can deal directly with the game. So that's really nice. In this case, I can use the game to do exactly what I want to. I can make the game actually manage that uncertainty by ignoring the keystroke if the user goes left too far or right too far. And that's an excellent thing. That's the role of the boundary from Bruce and the dog on the floor at Groxio Learning. We'll see you next time where we'll get to start to implement the score.